Hi guys, welcome to today's lesson, and we are talking about integration. Integration is the process of finding functions from derived functions, that is from their gradients. And you realize that during integration the power is increased by 1 and the new power formed is divided into the function. Now, this symbol is used to denote integration. This is to mean integration with respect to x, dx. For instance, if you are given a derived function, that's dy over dx to be equals to k x power n. Now, if I want to find y, the reverse of differentiation, I integrate this one with respect to x, that's dx. You find y equals to integration of dy over dx, that is y equals to integration of k x power n with respect to x. And I said that the power is added by 1 and then the new power divided into the function. So it will be x power n plus 1 divided by n plus 1, then plus a constant c, whereby I've said c is a constant and n must not be equal to -1. N should not be equal to -1. N should not be equal to -1. N is not equal to -1. So you realize that integration is just a reverse of differentiation. An example is a curve y equals to x squared. We differentiate this with respect to x, that is dy over dx. We get, differentiation with the power multiplies into coefficient of x and then reduces by 1. So the power here 2 will multiply here to be 2x power of 2 minus 1. So it will remain as 2x. So the differentiation of this of x squared becomes 2x. Now we can reverse this to get x squared. So we get y equals to integration of 2x. I've said the power increases by 1 and then the new power is divided into a function. So it will be 2x squared over 2, which becomes 2 cancels, which remains as x squared. So you realize if it's x squared, you differentiate, you get to x, you integrate, you get x squared. So you reverse the whole process. Example, find y if dy over dx equals to a 3x squared. So if dy over dx equals to 3x squared, I need y, I'll have to integrate. So y, it is the integration of 3x squared with respect to x, whereby I said it will be 3x power 2 plus 1 all over 2 plus 1. 3x power 2 plus 1 all over 2 plus 1. This is the new power that was formed, which is equal to, this becomes 3x cubed over 3. 3 and 3 cancels, it remains x cubed plus a constant c. This is how we integrate. That is our y. Our y equals to x cubed plus c. Now, when you have 4 dy over dx as 4x cubed, it will be 4 integration of 4x cubed with respect to x, which is equal to 4x cubed plus 1 all over 3 plus 1. The new power is 3 plus 1. So 3 plus 1 divided by 3 plus 1. So it is 4x cubed, x power 4x power 4 all over 4. 4 cancels, I remain with x power 4 plus c, plus a constant c. Now, you realize that we have two types of integrals. That is indefinite integral and a definite integral. So we want to deal with indefinite integral. Indefinite integral, these are integrals which have not been exhausted completely. That is, they involve the arbitrary constant of integration. They involve c because they have not been exhausted completely. So definite integrals is opposite. They do not involve c because they are exhausted completely. So we shall look at them later. So for instance, this one, if we integrate 2x power 5, or what we have even integrated from above, they are indefinite integrals because they contain a c at the end of it. There is no particular equation. There is no particular equation because you don't have the value of c. If you don't have the value of c, then that is an indefinite integral. For instance, 2x power 5, if I integrate this with respect to x, it will be integration of 2x power 5 dx, which is equal to, now it is 2x 5 plus 1 over 5 plus 1, which becomes 2x power 6 over 6. This 2 cancels here to be a third, so it will be, that's plus c, it will be equal to a third x power 6 plus c. A third x power 6 plus c. If I integrate this, I'll have to integrate each part separately. I have to integrate each part separately. Integrate each part separately. Now, we start with 5x cubed. It will be 5x cubed plus 1, x cubed plus 1, all over 3 plus 1, then minus 2x into power 1 plus 1 all over 1 plus 1, 2x 1 plus 1 all over x plus 1, then plus 4. Remember, x has a power of 0 here. X has a power of 0, and that is n number, or anything raised to power 0 is 1. So that is 1 times 4 is 4. So x has a power of 0 here, so it will be 4x power of 0 plus 1 over 1, which becomes, in this case, if we start with here, so this is x power 4 over, so 5 over 4, 5 over 4, x power 4, minus, this is 2x squared over 2, 2 and 2 will cancel, it will remain with minus x squared, then plus, this is 0 plus 1, remember this is x power, this is supposed to be power 0 plus 1, which is the same as 4x power 1 over 1, x power 1 is the same as x, and number is to power of 1 is that number. So we shall remain with 4x. So it will be 5 over 4 x power 4 minus x squared plus 4x plus c. The arbitrary c constant. So how do we find the arbitrary c constant? How can we find c? The arbitrary constant of integration can only be determined if further information about the variables in question is given. If you are given some further information about the variables in question, that is the x and y, that is the only time you can find the value of c. If you are not given the values of x and y, there is no information given about them, you can never find the value of c. So example, find the equation of a line whose gradient function, that is dy over dx, equals to 2x plus 3. This is the gradient function. We are finding a line, equation of a line whose gradient function is this, and passes through this point. So you are given the value of x and y where it passes. So first of all, we need to integrate this to find the value of y. So it will be integration of 2x plus 3 with respect to x. So it will be 2 integration of 2x plus 3 with respect to x, which is the same as 2x, it is power of 1 plus 1, 2x power of 1 plus 1 over 1 plus 1 plus 3 x power of 0 plus 1 all over 1, which remains 3x. plus c, which is the same as 2x squared over, remember 2 and this is 2, 2 and 2 cancels, so it remains x squared plus 3x plus c. And we are told here that x is 0 and y is 1. So when x is 0 and y is 1, it will be equal to, so we shall say that, remember this was y, so y is 1. 1 will be equal to, wherever we have an x, we substitute with 0. So here is 0 plus c. So 1 equals to 0 plus c. Therefore, c is equals to 1. Because 0 plus 0 is 0 plus c. So c is equals to 1. C equals to 1. So if you have c equals to 1, and therefore we have a particular equation. Hence the particular equation is y equals to x squared plus 3x plus 1. Instead of c, we substitute 1. So that is how we find the value of c for us to get a particular equation. Number 2, find v in terms of h. If dv over dh equals to 3h squared plus 4, whereby v is equals to 9 and h is equals to 1. So we find v. So that means v will be equal to integration of 3h squared plus 4 with respect to h. So that is 3h squared plus 4 with respect to h, which is the same as 3h cubed, because 2 power of 2 plus 1 is 3 over 3 plus, this is 4h, because h has a power of 0 plus 1, it remains h power 1 over 1, so which is h. So it will be 4h. So it is 3h cubed over 3 plus 4h plus c. These 3 cancels, it remains h cubed plus 4h plus c. And we are told v is 9 when h is 1. So whenever we have a v, we shall say 9 and h is 1. So 9 equals to 1 cubed plus 4 times 1 plus c. So that we find the value of c. So this is 1 plus 4 is 5. So that means my c becomes 9 minus 5, which is equal to 4. My c equals to 4. And therefore, the particular equation is v equals to h cubed plus 4h plus 4. So we substitute with the c here, 4 with the c here to get the particular equation. Question number 3 is that a curve passes through the point 3, negative 2. A curve passes through the point 3 and negative 2. As the value of x there is 3 and the y is negative 1. And its gradient function is 2x plus 5. Find the equation of the curve. So if you are told the gradient function dy over dx is 2x plus 5, we are asked to find the equation of the curve. So we integrate this to find y. So y equals to integration of 2x plus 5 with respect to x. So you integrate this, it will be 2x squared over 2, 2x squared over 2 plus, this is 5x power 0 plus 1, this is 5x, then plus c. You integrate this, 2 and 2 cancels, it remains x squared plus 5x plus c. And you are told y is negative 1, so we shall say negative 1 equals 2, and x is 3, equals to 3 squared plus 5 times 3 plus c. And therefore, remember, this is 9 plus 15. 9 plus 15 gives you 24. 9 plus 15 gives you 24. So 24 plus c. We remain with c here. It will be negative 1 minus 24. If I bring 24 this other side, it will be negative 1 minus 24 equals to c. So c equals to negative 1 minus 24, which is equal to negative 25. And therefore, the particular equation that we are needed to find here, the particular equation that we are asked to find, the equation of the curve, will be, now this equation we substitute c with negative 25. So it will be y equals to x squared plus 5x minus 25. This is the particular equation, the particular equation for the curve that we are asked This is the particular equation for the curve that we had asked. That is how we find particular equations. Now, definite integrals. When we talk about the definite integrals, there are integrals which have been exhausted completely. The function integrated with specified limits, like we have limits BA, you integrate y with respect to dx, where a and b are limits, and this is what we call a definite integral. A is the lower limit, and b is the upper limit. An example, we integrate or we evaluate limit 6 to we evaluate 2x cubed, 2x squared plus 3 with respect to x. So you need to follow some of the steps as follows. First of all, you need to integrate 2x squared plus 3x with respect to x, and this gives you, remember this is 2 plus 1, it becomes power 3 over 3, so it becomes 2 over 3 x cubed plus 3x. Because x was power 0 plus 1, it becomes x power 1, so it becomes 3x over 1, it is 3x. So it is 2 over 3x cubed, 2 over 3x cubed plus 3x plus c. Now, if we place the integral in the square bracket, that's the second thing that you need to do, is to place the integral in square brackets and insert the limits. These are square brackets, you insert the limit 6 2, because the limits were given are 6 2. After placing it with 6 2 here, the third step is to substitute the limits. So we substitute like 6 with x here. 6 with x, it becomes 2 times 2 over 3, that is, times 6 cubed, times 6 cubed, plus 3 times 6, then plus c, which gives you 162 plus c. And then we also substitute x with the 2. If we substitute with the 2 now, this is supposed to be 2 here, it will give you 2 over 3, 2 power 3 plus 3 times 2 plus c, which gives you 34 over 3 plus c. 34 over 3 plus c. Now, the next step is we subtract the results of the lower limit. We subtract the results of the lower limit from that of the upper limit. That is the upper limit results minus that of the lower limit. So this minus this. Remember, if we subtract, c and c always cancels. So it is this minus this. So if we open the brackets, it will be 162 plus c minus 34 over 3 minus c. So this positive c and c, it cancels out. So we shall have 162 minus 34 over 3, which gives you 150 and 2/3. 150 and 2/3. So what you learn from here, and that is why I said that is from definite integrals, that it involves a constant c. This one is completely solved because the constant c will usually always cancel out, and therefore when you summarize everything, you realize that when you are dealing with definite integrals, you even don't write the c. Because it will cancel out at the end of it. When dealing with definite integrals, when you are given the limits. There is no need to write the c because the c usually cancels out. Now, example number 2 is that we evaluate. You are given a limit of 1, 0, x cubed, x power 4 minus 5 with respect to x. So you put them into the square brackets with limits 1, 0. So you integrate this. If you integrate, it becomes x power 5 all over 5. X power 5 over 5 minus 5x minus 5x, because it's 5 power of, that is x power of 1 over 1, which remains as 5x. Now, you substitute 1 to both of them. If I substitute 1 here, the value of 1, So it will be 1 power of 5 over 5, which is 1 over 5, then minus 1. What you get, then you minus that of the lower limit. You substitute with 0, this is 0. If you substitute with 0, it becomes what? This is 0 over 5 minus 0. 0 over 5 minus 0. Remember, 0, all this becomes 0. So we remain with 1 over 5 minus 5, then minus 0. So 1 over 5 minus 5, it remains as negative 4 and 4 over 5. Negative 4 and 4 over 5. So this is how you solve this. Number 3, you have integrals, that is 2 and negative 1. You need to integrate negative x cubed plus 5x minus 2 with respect to x. So the first thing I've said is to put them into square brackets, that is the limits of 2 and negative 1. You integrate this, it gives you x power 4 over 4 plus 5x squared over 2 minus 2x minus 2x minus 2x, that is with respect to, that is integrals of 2 and negative 1. We substitute 2 to the whole thing, we subtract the negative 1 limit. So 2 here, it becomes 2 power 4, 2 power of 4, it is 16. 16 divided by 4, it is 4. There is a negative, so it will be negative 4 plus, this is 2 squared is 4. 4 times 5 is 20. 20 over 2 is 10, so it is plus 10 minus 2 times 2 is 4, so it's minus 4. That is our first integral, that is when we are using the limit of 2, minus the limit of 1 substituted here, so it will be negative 1, power of 4 is still negative 1, that is negative 1 times negative 1, so it becomes positive 1 over 4. So it will be positive 1 over 4, then plus, here negative 1 squared is just 1, times 5 is 5 over 2. So it's plus 5 over 2, then minus, then we have negative 1 times 2 is negative 2, there is a negative, negative becomes positive, so it will be plus again 2. All these are positives, so you minus here. So we shall have, this one gives you what? Negative, this is 6, that is negative 4 plus 10 is 6, because 6 minus 4 it becomes 2, so it will be 2 minus, if you add all this gives you 4 and a quarter, so minus 4 and a quarter, it will give you negative 2 and a quarter, negative 2 and a quarter. So that is how we integrate with respect to the x when given limits. Now we have another one here, 3, 2, we integrate 3x squared minus 4x plus 5 with respect to x. So we shall have 3, this is x power of 2 plus 1, it becomes power of 3, 3x cubed all over 3, 3x cubed over 3 minus 4x squared over 2, 4x squared over 2, then plus 5x with respect to the limits are 3 and 2. We substitute this one, if you simplify, 3 and 3 cancels, it becomes 2. Yeah, it will be 3x cubed minus 2x squared plus 5x, 3, 2 limits. So I substitute 3 first so that I minus the other one. If I substitute 3 here, 3 with this, it will be 3 cubed, which is 27, 27 minus 3 squared is 9 times 2 is 18 minus 18, then plus 3 cubed, plus the last one, 3 times 5, which is 15. Then we minus with 2, we substitute 2 with x here, minus the lower limit, substitution of lower limit, which is 2 power 3 is 8, then minus 2 squared is 4 times 2, 8, minus 8 plus 2 times 5 is 10. 8 and 8 is 0. This becomes positive 10. This is when you work out here, we shall have 27 minus 18. Then or what we get here, we minus 10, you will get 14. So if you integrate this one with respect to the limits given, you shall find 14. Now let's talk about area under the curve. Area under the curve. To find the exact area enclosed by the curve y equals to x squared, the x-axis, the line x equals to 2, and the x and the line x equals to 4. Like if we draw that such a curve, this is the curve y equals to x squared. Then the point x equals to 4 is here, and another x equals to 2 is here. This is the line x equals to 2, x equals to 2, and the line y equals to 4. X equals to 4. And then we have the x-axis. So we are asked this area, the shaded part. This is the area we are asked. To find the area we are asked here, we have the limits 4, 2. So we integrate this curve y equals to, that is x squared, with respect to x, with limits 4, 2, for us to find the area here, for us to find the shaded area here. So if I integrate this, it will be x power of 3 over 3. So it will be a third x cubed power of 4, with limits 4 and 2. We substitute 4 here, it will be 64 all over 3, 64 because 4 cubed is 64 all over 3, 64 over 3. Then we minus the limit of 2, the lower limit, that is 2. 2 cubed is 8 over 3. So if you minus, remember we are dealing with the area, so it will be, if you minus 64 over 3 minus 8 over 3, you get 18 and 2/3. Because we are dealing with area, it is square units, because you are not told it's centimeters, it's meters, it's whatever. So you write 18 and 2/3 square units. You don't know the units. So you write square units as the area. Number 2, find the area of a region bounded by the curve. By the curve y equals to x cubed minus 3x squared plus 2x. The x-axis and the line x equals to 1 and the line x equals to 2. So you sketch the curve. This becomes your curve x cubed minus 3x squared plus 2. This is the sketch of the curve. Then we have the point, the line x equals to 1 will be here. This is the line x equals to 1. The line x equals to 2 is here. So we are asked this part. The shaded part here is what we are asked. For us to find, we use the limit. We integrate this curve. We integrate this curve with respect to the limits of 2 and 1. So we shall have limits of 2 and 1. We integrate the curve. It gives you x power 4 over 4, x power 4 over 4 minus 3x cubed over 3, which gives you 3 and 3 cancels, which gives you x cubed, then plus 2x squared over 2. Remember, 2 and 2 cancels, it remains x squared, with limits 2, 1. We substitute the 2 here, we minus the limits of 1 substituted here. So we shall have 2, it becomes 2 power of 4. It becomes 16, 16 over 4, it becomes 4 minus, this is 8 minus 8, then plus 4. Then we minus the limits of 1, we substitute here, it becomes a quarter, minus 1 plus 1. So we substitute, it becomes this one, remember, this is 4 plus 4 is 8, 8 minus 8 is 0, minus a quarter. All these gives you, this is negative 1 plus 1 is 0, so it means a quarter. So it is 0 minus a quarter, which is equal to negative a quarter. Negative here indicates that the area is below the x-axis. It indicates that the area is below the x-axis, and therefore we disregard the negative, and therefore the area is written as a quarter square units. You just assume the negative, and therefore the area is a quarter square units. So when you get the area with a negative, the negative shows you the direction. So you usually ignore the negative and write the area as the positive. Now let's talk about a question like this one. We find the area enclosed by the curve x squared minus 10x plus 9. The x-axis, this curve, the x-axis and the line x equals to 4 and the line x equals to 10. So if you sketch the curve, we shall have, this is the curve. So we are asked the line x equals to 4, x equals to 4 is here. This is the line x equals to 4. The line x equals to 10 will be here. The line x equals to 10. So the area we are asked to find is this and this. For us to find the area of this and this one, we find with respect the area at the limits of 4 and 9. Whatever we get, this is the area. We integrate this one with these limits 9 and 4. What we get as the area here, we add the area here. That is, we integrate the same curve with the limits 10 and 9. With the limits 10 and 9. So that is, we integrate the same with the limits 9, 4. And the 10 and 9 limits, we integrate the same curve. So we shall find the integration of this as what? X cubed over 3 minus 10 squared over 2, which gives you 5x squared. Then plus 9x plus 9x, limits is 9, 4. The same integration with 10, 4 we add. Remember, we are adding the 2 with limits 10, 4. We are adding the 2 with limits 10, 4. So we substitute 9 here, you get all this. If you substitute 9 here, you get this one. Then we minus, substitute 4 here, you minus all this. You substitute 4 here, you get all this. Then you plus. Now we substitute 10 here, you shall get this. You substitute 9, you get the same. Whatever you got here is here. So what we get here and what we get here, we add the 2. These first ones gives you negative 58 and a third, and this second ones gives you 4 and a third. Remember, we know the negative, so ensure you drop the negative, because if you add negative 58 plus 4, remember it will be still negative. It goes backward to around negative 54. It goes to around negative 54. So if you make such a mistake, you get the wrong answer. So what you do, you drop the negative so that you add the 2 direct, because I've said that area, the negative shows you the direction. Like this one, the negative shows you that it's below the x-axis. It's below the x-axis. And this one, because it's above the x-axis, does not have the negative. It is 4 and a third. So the negative shows you that it's below the x-axis. So what you do, you add 58 and a third plus 4 and a third, which gives you 62 and 2/3 square units. 62 and 2/3 square units. So usually ignore the negative, then add the 2 to get the area of the shaded parts. So you usually must ignore. And then remember, sometimes you can be given a curve and another line, equation of a curve like the one we are given, and equation of a line. You are asked to find the coordinates where the two intersect. Even if when you are given such a question, what you do, you solve the two simultaneously by using substitution method or elimination method. Mostly we use substitution because you realize you shall be having a curve that is cubed and all that. Just make one from the equation of a straight line, make one the subject, substitute in the second one for you to get the coordinates where they intersect. And the coordinates will also give you the limits that you shall use to solve such an equation. Now, number 4, find the area enclosed by the curve y equals to 9x minus x squared and the line y equals to x. Like this one, you are given the line y equals to x, this is the line y equals to x, and the curve y equals to 9x minus x squared. Now what you do here, remember you don't half. you don't have the limits. For you to find the limits, remember we are asking this side, the shaded part. So you need to find the coordinate here, the point of the value of x at this point, the value of x at this point, and the value of x at this other point. Of course, here you can say the value of x is 0, but just use substitution like I said. So y equals to x. Whenever I have a y here, I put whenever I have a y here, I put an x. So I put an x here, it will be x equals to 9x. X equals to 9x minus x squared. So I put the like terms together. This becomes, if I bring x squared this other side, or I bring x here, it will be 9 minus x, 0 equals to, if I take this other side, it will be 9x minus x, it is 8x minus x squared. So I factor this out, I will have x into 8 minus x equals to 0. So x equals to 0, or 8 minus x equals to 0. That means I take x this other side, it is x equals to 8. So I shall have x equals to 0 or x equals to 8. Meaning that my value of x here is 0 and my value of x here is 8. So the limit is 8, 0. The limit is 8, 0. I don't need to find the value of y because it does not assist me in this case. What I needed is the limits, and the limits now are with here, the coordinate. If you are asked the coordinates, I also found the value of y, but I don't need it. I need only the value of x's to get the limits. So I need to integrate. For I to get the value of the shaded path. For me to get the area of the shaded part, I integrate the curve with respect to 8 and 0. Then I minus this line. I integrate the line with respect to again 8 and 0. So I integrate the curve with respect to limits 8, 0. I minus that of the line with respect to, that is limits 8, 0. So this one integration gives you 9x squared over 2 minus x squared, x power of 3 over 3 with limits 8, 0. Then I come to y equals to x. I integrate x with respect to x, limits 8, 0. So it is x cubed. This was, no, it becomes x squared, not x cubed. This is supposed to be x squared over 2, 8 power 0. Now, this becomes, I substitute an 8. For a 0, remember for a 0 it will just be 0. So there is no need to deal with the zeros. Deal with 8. Substitute 8 here. If I substitute 8 here, I don't need to minus the 0 because the 0 is 0 still. So I substitute the 8 here, it gives me 117 and a third minus. If I substitute just the 8 here, 8 power of 3, or I mean 8 squared, which is 64, not cubed. 8 squared is 64 because this was supposed to be squared. 8 squared is 64 over 2 is 32. So I find with 8 here, 117 and a third minus 32. This gives me 85 and a third square units. 85 and a third square units. So that is the area of the shaded part. Now, application of differentiation, of integration in kinematics. How do we apply this? When we talk about differentiation, you move from displacement to velocity, then velocity to acceleration, you differentiate. But if you are going the reverse, acceleration to velocity, you integrate, velocity to displacement, you integrate. So moving upwards, you integrate, and from displacement to acceleration, you differentiate. So after understanding that integration, you go the reverse of differentiation, and then you are done. From there, you can do such an example like a particle moves in a straight line through a fixed point O with velocity 4 minus 1 meters per second. Find an expression for its displacement s from this point. given that s equals to 4 and t equals to 0. So first of all, you need to know that the velocity, you're given the velocity, and we know velocity is ds over dt is equals to this. So for you to find s, you integrate the velocity. So I integrate this velocity with respect to t. It gives me, that is, I integrate this one, gives me 4t minus t squared over 2. 4t minus t squared over 2 plus c. Now I substitute s4 and t0, s4 and t0. I substitute s4 and t0 for me to get the value of c. For me to get the value of c. So if I substitute to get the value of c, that means whenever I have an s, this is my s. So 4 equals to 4 times t, which is 0, minus t, t I'm told t is 0. So it is minus 4 times t, which is 0. 4 times 0 minus 0 squared over 2 plus c. Remember, this is 0 minus 0, this is 0 still, so c equals to 4. So 0 minus 0 is 0, so c equals to 4. C equals to 4. And therefore, if I write the equation, because what I'm asking is an expression for the displacement, so displacement equals to 4t minus t squared over 2 plus 4. Plus 4. So that is how we do. Number 2. The velocity v of a particle is 4 meters per second. Given that s equals to 5 when t equals to 2 seconds. Given that s equals to 5 when t equals to 2 seconds, find the expression of the displacement in terms of time. Now I'm told about velocity. So that means ds over dt equals to 4. ds over dt, which is velocity, equals to 4. So that means to find s, I integrate the velocity given. I integrate 4 with respect to t. So integrate to get s is integrate 4 with respect to t, which is the velocity. So s equals to 4t plus c. I need to find c. I'm told s equals to 5 and t is 2. So 5 equals to 4 times 2 plus c. So this is 8 and this is 5. To get my c, it is 5 minus 8. 5 minus 8 equals to c. So c is negative 3. And therefore s equals to 4t minus 3. 4t minus 3. Wherever I have a c, I substitute with the negative 3. So it will be my s equals to 4t minus 3. Part B. I find the distance moved by the particle during the 5th second. 5th second, if you remember, at a given instant, if you remember in differentiation, 5th second, that means we find the limits of 5 and 4. 5 and 4. So the 5th second, at the 5th second, we find the limits of 5 and 4. So, first of all, we find the distance moved. So we integrated to find s as 4t minus 3. So the 5th second is given by, now we put the limits of 4t minus 3 with what? With 5 and 4. So 5 times 4 is 20 minus 3 is 17. Then minus, remember it's already integrated. Minus 4 times 4 is 16. 16 minus 3 is 13. So it will be 17 minus 13, which gives you 4 meters. So that's the distance during that 5th second. Number 3. A ball is thrown upwards with a velocity of 40 meters per second. This is the velocity given, meaning that ds over dt is equal to 40. So determine an expression in terms of t for its velocity. So first, for its velocity, we are told about the velocity and you are given the velocity here. Remember, for you to get the velocity, you can you integrate acceleration. So that means my dv over dt, remember, is thrown upwards. So it's going against the gravity. And we know Gravity, it is 10, that is acceleration. The gravity is the same as acceleration, which is 10 meters per second square. So if I integrate acceleration, which is dv over dt, dv over dt is equals to negative 10, because now you are going against the gravity, is negative 10. So if you are given negative 10, if I integrate with respect to t, I can easily find, I integrate with negative 10 with respect to t to find my velocity. So v equals to now negative 10 t plus c. Negative 10 t plus c. Remember t is equals to 0. T is equals to 0 because I'm told that the ball is thrown upwards with the velocity of this. So when it is thrown upwards, the time at which it is thrown at the initial velocity or acceleration, time is equals to 0. At initial velocity or acceleration, time is equals to 0. So when t is equals to 0 and v equals to 40, so I'll have to substitute and say that is 40 equals to 0 plus c, meaning my c equals to 40. And therefore the equation is negative 10t plus 40. Plus 40. Negative 10t plus 40, which is the same as 40 minus 10t. 40 minus 10t is my v. Now I need to find the same expression for the height above point of projection. So we know that ds over dt equals to v, which is the same as 40 minus 10t, like we have found from above. So if I integrate, this one gives me s, displacement. So my displacement becomes, I integrate this one, becomes 40t minus 10t squared over 2, which becomes 5t squared plus c. So my displacement equals to 40t minus 5t squared plus c. When t equals to 0, and that is at initial velocity, at the initial acceleration, t is equals to 0. And if t is equals to 0, that automatically tells you that the displacement is also 0, does not move. And therefore it has not moved. So displacement is also 0. And therefore c at that initial displacement, c is also 0. Because if all this is 0, then c is also 0. 0, 0. And therefore even this one is 0, that's the displacement, and therefore c is what? Is 0. So the equation becomes, this one c is 0. It becomes 40t minus 5t squared. So that is the displacement. The expression for displacement will be s is equals to 40t minus 5t squared. At the point of projection, where you started to project, t was 0 and there was no displacement. It did not moved. It was also 0. So you substitute, find s is equals to 40t minus 5t squared. And part B, you realize that v is 40 minus 10t. So we are, part B, we were asked to find the velocity and height after 2 seconds. Velocity and height after 2 seconds. So velocity and height after 2 seconds. Remember v is 40 minus 10t. So after 2 seconds, when t is equals to 2, we substitute with 2 here. So v becomes 40 minus 10 times 2, which is 20. 40 minus 20, v equals to 20 meters per second. And we are told velocity and height. Height is displacement after 2 seconds. So displacement will be what? You substitute with 2 here, it becomes 80. 80 here minus 10. So it will be, minus this 2 squared is 4. 4 times 2 is 4 times 5 is 20. So this is 80 minus 20 is 60. So displacement after 2 seconds will be 60 meters. 60 meters, and the velocity after 2 seconds is 20 meters per second, and displacement after 2 seconds is 60. You substitute with 2 here is 60 meters. That is, you've answered part B of the question. Part C of the question, we find the maximum height attained. And we understand maximum height will be attained when you reach at your destination. The velocity, if you are running at a very high speed, at that point you stop, meaning you are going at a stop. So at maximum height, you always, because at maximum distance where you have reached your stop, velocity becomes 0. So at maximum height, v equals to 0. So far, if I substitute my v with 0, it is 40 minus 10t is equals to 0. From then, 40 is equals to 10t and t equals to 4. If I have t as 4, I substitute with the t at the displacement to find the height. So I substitute t here with 4, it becomes 40 times 4 minus 5 times 16, that is 4 squared is 16. So it becomes 40 times 4 is 160, 16 times 5 is 80. So it will be S is 160 minus 80, which is 80 meters. So the 8 meters is the maximum height attained. Is the maximum height attained. Question number 4. The velocity v of a particle is 4 meters per second. Given that s is equal to 5 when t equals to 2 seconds, find the expression of displacement in terms of time. So, I'm given the velocity, and we know v is equal to ds over dt, which is equal to velocity, which is equal to 4. So, my displacement, it is 40 plus c. And I'm told that s is 5 and t is 2 seconds. So, I substitute 5 and t, so my c becomes 5 minus 8, which is negative 3. I had done this question from above, so this is just a repetition. So what you do, my s now becomes 40 minus 3. Then we find the distance moved by the particle during the 50 second. During the 50 second, like I said from above, is that the integration that you did for s, you substitute 5 and 4, so you'll find 4 meters. Distance moved by the particle between t equals to 1 and t equals to 3. So where you have here, you substitute 3 and 1, and then you substitute 3 here, you minus that of 1, for you to get 9 minus 1, which is 8 meters. So that is between 1 and 3. So the limits will be 1 and 3. 3 and 1. So you substitute and you get 8 meters. So that is the end of my presentation today. Continue subscribing and following my channel to get more on mathematics, high school, Form 1 to Form 4 in the Kenyan 844 system. Thank you for following me.